Unified management of sound effects is achieved. Next, we need to add sound effects to the game according to different situations. To achieve the effect of simulating the real environment. When the basketball collides with various objects, it will make a sound. Open the basketball control script, and find the collision detection method. Add a sound effect management method to it to set the sound of the basketball colliding with various objects. Create a new layer. At the same time, in the enumeration class layerEnum, add the corresponding layer. Set the layers of the backboard, basket, and net respectively. After saving, make a new basketball hoop prefab. Use the new prefab to generate the basketball hoop. Unlock the node. Adjust the position and rotation angle. Go back to the unfinished method just now. Play different sound effects according to the different levels of the node where the collision body collides with the basketball. Save and run. Test. It is found that the time of sound effect playback does not perfectly match the timing of collision. At this time, you can use sound editing software to edit the sound effect. For example, use sound editing software or video editing software to cut off the blank parts before and after the sound effect. Here, I will use the pre-edited sound effect file. Re-import the sound effect resource and then rebind the sound effect resource. Save. Run and test. It is found that the effect is basically normal. However, careful students will definitely find a problem. The sound of the basketball hitting the ground from different heights is definitely different. That is to say, as the basketball bounces lower and lower after landing, the sound of its collision with the ground will also become smaller and smaller. What would you do if you encounter such a demand? Here, the strategy I adopted is to use a variable to record the number of times the basketball collides with the ground after a shot. This counter is cleared before each shot, and the counter is accumulated once each time the basketball collides with the ground. Then use an array to record the size of the sound of each collision between the basketball and the ground. Because the elastic coefficient we set for the basketball is 0.75. That is to say, the height of the basketball rebounding after each collision with the ground is 0.75 of the previous height. Theoretically, the sound of each basketball collision with the ground should be 0.75 times the previous sound. We can use Excel to quickly calculate it. Here we calculate 10 times enough. If you are worried that the basketball will collide with the ground more than 10 times in a shot, then the volume of the last time in the array will be used for the volume that exceeds the number. Select the data in Excel and copy it. Then paste it as a value. Save the volume row to 2 decimal places. Then copy and paste it into Notepad. Replace the space in the middle. Select all and paste it into the code. At the beginning of each shot, clear the number of times the basketball collides with the ground. Each time the basketball collides with the ground, the counter increases by 1. Then, when playing the basketball landing sound effect, a parameter needs to be passed. Let's first modify the method of playing sound effects in the Sound Effect Manager. Add a volume coefficient with a default value of 1. Then, modify the method call of the basketball landing sound effect in the basketball control script. Another thing to note is that in the sound management class, when adjusting the sound volume, the volume of the corresponding sound effect needs to be recorded. Save and run. Test. It is found that after the basketball lands, the volume of each collision with the ground is gradually attenuated. Adjust the volume test, and it is normal to shoot again. We found that during a shot, the basket may also collide with the basketball multiple times. The same method can also be used to simulate the effect of sound attenuation when colliding with the basket. First, select the sound attenuation array variable just now. Press F2 to change it to sound attenuation. Then, make corresponding changes as you set the sound of basketball landing attenuation. Similarly, make corresponding changes to the method of playing background music. When you test, you can adjust the size of each sound effect according to the actual listening experience. For example, when I was preparing for class, I found that the sound of the net and background music seemed a bit louder than other sound effects. So, I adjusted the initial volume of the background music to 0.2 and the initial volume of the net and basket sound effects to 0.6. Now, there is another problem. How to judge and implement the cheers when a goal is scored, the laughter when a shot misses, and the surprise when a shot is missed. The cheers when a goal is scored are easy to handle. Just add a line of code after the code for scoring the goal. The key is how to judge the 3 misses and the missed shots in the program. A 3 miss means that the basketball does not touch the backboard, the basket, or the net after the shot. A missed shot means that the basketball passes through the basket from top to bottom, and at most only collides with the net during the process of passing through the basket. What to do? The previous goal logic has a design that is not rigorous. Originally, a trigger was added to the center of the net. When the basketball collides with the trigger in the center of the net, it is considered a goal. What if the basketball passes through the basket from the bottom of the basket to the top and is also considered a score, which does not comply with the rules of the game? Now, let's modify it together. First, find the existing trigger node in the net. Copy the new trigger node. Adjust its position to 1 up and 1 down. Name them trigger up and trigger down respectively. Appropriately reduce the trigger below. Then hide mesh renderer. Then, add an array to the basketball control script. It is used to record the triggers that collide with the basketball during a shot. If this array records the upper and lower triggers in sequence, it means that a goal has been scored. Clear the elements of this array before each shot. Then in the trigger method, make a goal judgment. Record the name of the trigger node that collides with the basketball in the array. If the number of triggers that collide with the basketball is less than 2, it means that there is no goal. Copy the previous branch of the previous call method and make a slight modification. There is one question left: how to judge whether the shot is a three-pointer or a hollow ball. Similar to the goal judgment above, we can also add an array. It is used to record the level of the collider that collides with the basketball during a shot. Before each shot, clear this array element. Then, in the flight processing method, record the level of the object that collides with the basketball each time. If it already exists, it will not be recorded repeatedly. If the three-pointer means that it does not touch the backboard, the basket, and the net, then a condition needs to be added here. That is, when the basketball collides with the basketball stand, do not record the level of the collision body. The level of the basketball stand pillar is default, and the level of the basketball stand beam is holder. After the basketball collides with the ground, it means that the basketball has landed and the shot is over. Here, the audience sound is simulated. In the audience sound simulation method, first determine whether a goal is scored. If a goal is scored, determine whether it is a hollow ball or an ordinary goal. If it is a hollow ball, play a surprise sound, otherwise play a cheer. If there is no goal, determine whether it is a three-pointer. If it is a three-pointer, play a laugh. Because there are multiple places to use whether a goal is scored or not. So the goal judgment in the scoring judgment method is refined into one method. Comment out the logic of playing the goal sound effect. Improve the hollow ball goal method. If there is only one collider that collides with the basketball, and this one is the ground, it is a hollow ball. Where there are two colliders that collide with the basketball, the first is the net, and the second is the basketball, which is als. Oh, a hollow ball. Save. Run and test. It is found that not only the sound effect is not played when the goal is scored, but also the goal score is not updated. This indicates that there is a problem with the goal judgment. We add relevant outputs in the goal judgment method. Save. Test. It is found that we have added a camera trigger near the backboard before. When we record data in the trigger, we can exclude the camera trigger. Save. Run and test. It is found that after the goal is scored, there will be cheers every time the basketball lands. Tracing the code, it is found that the audience of voice method is called when the basketball collides with the ground. So every time the basketball collides with the ground, there will be corresponding processing. However, if it is placed below, the audience sound effect will not be played until the speed of the basketball is close to zero after landing. Obviously, the timing is not well controlled. We need to play the audience sound effect when the basketball lands for the first time. What to do? There are many ways to implement it. We can add an identification variable here to record whether the audience sound effect has been played. Before each shot, restore the value of this variable to false. Inside the audience of voice method, after each call, change the value of this variable to true. Before each call, determine whether it has been called. If it has been called, return directly. Save. Run and test. It has been verified that the sound effect is completely correct. However, when muting, a problem was found. The muting of the sound effect can only mute the currently playing sound effect, not all sound effects. First, we add the mute property to the sound class. At the same time, modify the construction method. In the sound effect management class, modify the mute method. In the mute method, traverse all sound effects and set their mute effects. Modify the method of playing background music and sound effects. Modify the method of initializing sound effects. Save. Run and test. The background music and sound effect muting are normal. Other sound effects are also correct. At this time, don't forget to regenerate the basketball hoop prefab. And use the new basketball prefab to get the basketball hoop at the other end of the basketball court.